Okay, do you have a headset on? Can you hear me at all? I'm not sure if people can hear me at all. Okay, great. Hi everyone. I see we have Horace here, Leonard's here, Jack Smith, my alter ego, is here. It's my 13-inch laptop. And we have Elisa Bell as well. So let's just wait a couple of minutes and see. I'm going to unmute so you guys can say hi.
Hey, how's it going?
Hi, Leonard. Can you hear us all right?
I can hear you all right, yes.
Hey, can you hear me?
Not sure I hear you. Rhea, do you get audio?
Can you hear me, Leonard, or no?
I can hear you guys.
Grant, can you hear me? Hello?
Can hear them. Okay, that's strange. My headset's not working. Let's try this. Yes, sir. Hello?
Hey.
Oh, the audio is always such a... Let me make sure I've got the right audio set up here.
Maybe just take your headphones out and shift you.
Okay. How's that? Can you hear me now?
Yeah, I can hear you. I can hear you.
Your volume on your computer.
There we go. Okay, there we go. How does that sound?
Yeah, sounds good.
Yeah, sounds good as well.
Oh, okay, great. So I think maybe we'll wait a couple more minutes. We are being recorded, and we'll see who else is going to be joining. I'll just check if there's any other people going to join. We did have about 12 people saying they would join, but I'm not sure who else will be joining. So this might well be an interactive dry run, and we will record it and maybe represent it at some time. So do you guys see my video at all? Do you see me?
I see your screen right now, and I see you at the top. I see you at the top. I see your face as well. Hey, Grant, I think you muted yourself.
Yeah, he did.
Oh, okay.
He is still muted.
I muted myself. Oh.
There we go.
That's strange how that happened. Okay. All right. So is everyone on? I don't see you, Lisa. Are you able to log in?
Yeah, I'm in. I'm just not projecting my face.
Oh, okay. Oh, that's interesting. So we'll only, so in the way we've set it up, we just see the panelists and not the other people. So I'm not sure who else is on, but welcome to this webinar entitled Blockchain, Sushi, and Supply Chain. So we're going to look at building enterprise blockchains with Hyperledger Fabric, and this is part 1 of the series. And in case you were wondering about the presentation slides, they are available at this GitHub URL. So we can make that available in the chat at the end, or you could just take a screenshot of that or write it down. And that takes you to my GitHub, which will have a bunch of links about the presentation slides and some other information, which we'll keep updating. So moving right along, I want to see if I can get my other piece of PowerPoint up on my other screen, which doesn't seem to be there. So I'm just going to, a few teething issues. So now, okay, good. So today's agenda, it'll be a brief introduction. We'll take a look at the blockchain basics, and then we'll delve into Hyperledger Fabric. Blockchain specifically, we'll look at some supply chain use cases. In this case, we'll be looking at sushi, coffee, and diamonds. Some very compelling use cases that IBM has actually tackled and brought and created partnerships and actually brought into fruition. Then we'll jump into a technical demonstration on how to see how the coffee fair trade code pattern that Array has put together actually works. We'll take a look at the code, and if we have some time, we might jump in and build a very basic demonstration from scratch. It's a tic-tac-toe, like a real hello world, just because it's super simple. And then wrap up in Q&A. Okay. So blockchain, how did this all come about? So in 2008, Satoshi Nakamoto wrote the pivotal white paper on Bitcoin, and he outlined the mechanism of blockchain. And the reason he did this was so that to allow for digital currency and solving the double spending problem. And years later, moving on, things have changed, and there's many different kinds of blockchains available to us. But generally speaking, all blockchains have a decentralized ledger that is append-only, and I like to think of this much like rows in a spreadsheet. So in one row, you might have a row of transactions, and in the next row, you'll have a cryptographic checksum or hash of the previous row. So for all the geeks out there of you, it's pretty much a linked list of blocks of transactions with the preceding next block having the hash of the previous block's content. And if that sounds difficult to comprehend, well, it's a little bit geeky, and we can get into it later if you like, and probably in part 2 of this series. But essentially, the cryptography that makes up the blocks ensures that the blockchain history cannot be changed or tampered with. So here we have a basic slide, which I'm going to spend a little time on, that basically explains what a blockchain is and how it's comprised. So I'm going to try and use this new feature in PowerPoint, the actual laser pointer, which is quite fun. So the whole idea about blockchain is, as long as you have a community or a cooperative business consortium, then it's a good use case to actually use a blockchain. So in this case, the people in the community will either trust each other implicitly, or they might be competitors, but they'll trust each other enough to share enough information to make the general ecosystem useful for everybody. Much like, say, in the gambling world, if you are a card counter, they share that information amongst all casinos, and that is sharing some information, but not everything. So at any rate, this consortium of members and participants would have a common business goal. And so these blockchain architectures give the participants the ability to share a single source of truth. And this is exactly what is the blockchain ledger. So the ledger is represented here by these what's that, a hexagon, and everyone has the same, notice everyone has exactly the same hexagon and has visibility to the same hexagon. So this is the distributed ledger, and this distributed ledger is shared amongst multiple participants in the blockchain network. So in this case, we have a factory, we have perhaps a business or seller or market, we have a bank managing the finances, transferring money, we have a shipping agent, we have regulation in some cases, and then in the final case here, we might have a sort of buyer, or like a supermarket. So notice this is decentralized. There's no one single manager of the network. So there's certain pros to this. So the number one is, I would say, is this prevents duplication of data, and also error-prone data. So in some databases, you might have a record entered by some data entry person, and then in another database, or even in a paper ledger, it might have been written in illegibly or mistakenly. So you have a very costly and time-consuming auditing and reconciliation process. So these are the pros of actually using the blockchain networks. So basically, every time a transaction occurs, so a transaction might be, a product leaves the factory to source, it goes to the market. So that might involve like a bill of lading onto a truck. So that's considered a transaction. So every time a transaction happens, this transaction is transmitted into the network, and only if the majority of the members agree of this, we will get something called consensus, that this is a valid transaction, and then that will be written into the blockchain for everyone to see. So other aspects about this this private, trusted, permissioned blockchain is, the fact is, like I said, not all of the information is privy to everybody in the network. And this is a little complex, but it's basically brought about by the concept called channels, which is a little bit out of the scope of this talk, but the channels allow for certain information to propagate between certain parties. So you may not want to, have, business one and business two sharing, profit and loss statements, for instance, but the banks might be privy to those. So that way privacy is ensured. So last few items on this list I'd like to bring notice to is this idea of provenance. So provenance essentially is, where are things sourced from, what's the history, where what is the life cycle of the event of the asset. So in this case, in the supply chain, something was sourced at a factory and it was shipped around eventually back to the supermarket. So the idea is you'll be able to trace this, and this is known as transparency. The ledger is visible to everyone, and so it's very easily identified where and how the item is in its life cycle in the economic process. Another very important point of the blockchain is the mutability. So mutability is really important, meaning the blockchain cannot be altered or tampered with without breaking the cryptographic aspects of the blockchain. So if somebody does try to tamper with the records, it becomes very quick how this can happen. And lastly, finality. So that means there is only one place to determine the ownership of an asset or completion of a transaction. So this is the whole idea of the shared replicated distributed ledger. So, like I said, there are many different kinds of blockchains. IBM, back in February 2016, became a founding member of the Linux Foundation and taken some of their initial proof of concepts and research and donated it to the Linux Foundation's Hyperledger project. And this is really important because now, being an open source project, anyone can contribute to it, and it can be used and improved in the in the vein of open source, which is very exciting. Right now we are sitting at Hyperledger Fabric version 1.4, and the exciting part about this, it's really ready for business and enterprise. It has long-term support. However, as you'll notice down here, Hyperledger Composer, which is the way we used to build and construct these Hyperledger Fabric networks, is actually being deprecated, and these are the challenges now of us contributing back to the Hyperledger project and creating SDK aspects which will allow Hyperledger Fabric composition to happen outside of an actual Hyperledger project. And in fact, we'll find out soon enough that we'll be using Visual Studio Code in order to do that. So, in terms of what what are we really talking about today in terms of blockchain? We're going to kind of focus on supply chain, and there are many different supply chains, of course, in global context. And the one I'm very interested in is food, and one of my favorite foods being sushi. So I've been working with Leonard Franzel, Dr. Leonard Franzel in San Francisco, and he also has contributed to this presentation and showed me some of the finer points of it. And he recommended this book, and I highly recommend this book too, because it really talks about the globalization of where the fish comes from, how the manufacturing process is involved, the warehousing, the distribution, safety, and just generally how sushi in the 70s, was purely a Japanese phenomenon. They were running out of tuna, so they started to import tuna from America, and then vice versa in the 80s. Sushi became popular in America, so now all of a sudden we had to feed the American markets, and these pretty much were exclusive restaurants. And now today, of course, you can buy sushi or even in your local deli. So here we have the basic map of sushi in a supply chain today in the global economy, and realizing that it is the gold of the fish. Down here we see a fish at a market. It pretty much reached $3.1 million to buy this tuna. It was 1,200 pounds. So it really has become, bluefin tuna is really the sort of, the ultimate in sushi now, and which is strange considering at one point it was really considered dog food or pet food. So here's the supply chain with the links. So basically from hook to plate, we can see it traveling through the fishermen, shipped through airlines for speed, through refrigerated containers on container ships, then refrigerated containers again on trucks to the markets, ascertained, auctioned to the chefs, and then onto our plates. So what's the advantages of having a blockchain around a supply chain like fishing and sushi, for instance? We can identify, once we have a blockchain and we participate in this blockchain, agents and chefs and suppliers and processing plants can quickly identify faults in the system. And a couple of things here that come to note is the unscrupulous pirate fishing. Here we see some boats off the coast of Korea, and they pretty much account for between 11 and 26 million tons annually, or about 33% of the world's total legal catch. So there's a lot of unscrupulous activity going around where our fish comes from, and if it is pirate fishing, are they treating it correctly? Are their temperature controls up to standard? And is the fish safe? Similarly, even on the shipping front, we can notice over here that in fact, this container ship had a fire, and the Internet of Things sensors within these containers would have reported back into the supply chain, and we would immediately know that certain shipments were actually could be contaminated or delayed. So that would improve the supply chain. So I'd like to spend a minute just saying, well, we're not only going to talk about food like sushi, rice, etc. There are a couple of other use cases which come to mind, which IBM has also taken on and created partnerships around. So diamonds and coffee also play into the role. Okay, so this is the food trust. I'm sorry, yeah. So let's go one by one. So IBM Food Trust is IBM's partnership with Walmart, and they've created a partnership to create a supply chain with blockchain that uses under the covers Hyperledger Fabric. And this is a very successful project. And again, it's all about bringing us healthy food from farm to table or fork to table in a world where it's hard to trust where you get your food from. If it's sitting in a refrigerator in a supermarket, you don't actually know who the grower was. But given this transparency of the blockchain, we can actually track and see where the food came from and was it, correctly handled and shipped, much like the sushi. Another one that's of great interest to me, of course, is jewelry. I come from a long line of jewelers in my family. Indeed, these are artifacts that my father gave me when I was younger. So we do see jewelry and rings and gold and precious metals and diamonds. And IBM, in fact, has also created a relationship with Helzberg Diamonds, which is a retail jewelry store, and it's the IBM Trust Chain, and there are some articles about it. And really the main idea here is, to efficiently track and improve the origin and ethical sourcing of these precious stones making up the jewelry and, of course, the gems. So we're looking for things like blood diamonds and, any sorts of perhaps refinery standards that have not been adhered to. Perhaps the quality of the metals were not up to scratch. So is it really an 18 karat gold, or maybe it's 17.5? We're not sure. But by having the blockchain and having all the members in a consortium, it might allow for us, knowing what we're buying is really good. So we're going to sort of switch gears now to coffee. So we're back to the Food Trust's blockchain scenario again. So it's coffee time. I love coffee, and it's very important for me, at least, to know where my coffee came from. Did it come from Brazil? What its flavors are like? Who produced it? And who the barista was. There's a lot of elements in having a really great cup of coffee. So this is all explained and shown in a demo we have here, which I'm going to bring up now in the browser, if I may. Afraid I'm going to have to click off this. I have to turn off my laser pointer. 1 second, I apologize. Didn't need to do that. I'm just trying to copy a URL. Let's see. Okay. It's not that URL. It's supposed to be this 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 URL. It's Sorry about this. How should we grab this URL? I apologize about this. I'm going to have to just jump into, oh, there it is. So this is a demonstration Hooray Portier, one of my peers and mentors also in the Bay Area, put together, pretty much as a marketing showpiece, but it is very nice. And it explains how coffee beans are sourced ethically with fair trade and allows us to track a cup of coffee. So the idea is you would have some sort of identifier for your coffee cup. Here we have one, NJB123. We might be able to change that to 1235 for instance. And we're just going to submit it into the blockchain running on the IBM cloud. So I'm going to submit it. And immediately I get back some interesting information that comes off the blockchain that is in part of this supply chain. So we can immediately see where the coffee came from, who roasted it, who my barista was, how the drink was prepared. Was it a cortado? Was it was it espresso? In this case, it's a cold brew nitro, I believe, and what time it was served. So that's all very well and good, but we can further go on and see, well, what else happened? The coffee was evaluated, and this is the grade samples of the Hyperledger beans. Sorry if I pronounced that wrong. But nevertheless, we can see here somebody called Brian had indexed and assigned values to some of the aromas, flavors, aftertastes, and other metrics that make up a score of how the coffee was evaluated. Similarly, we can take a look at the importation of the coffee, and we can see some very nice things. How many bags came? What was the humidity in the container? Were the containers damaged? Or was there any visible insect infestation? And furthermore, we go back in the blockchain. So here you can see this is the blockchain's provenance of where the coffee came from. So now all of a sudden we see shipping information, which is interesting too. So we saw the routes and what vessel it was on and the actual voyage number. And in fact, if we wanted, we could actually see this data in the blockchain. So if we click on this, let's see what we see. So everything in the blockchain is stored as JSON, and you can pretty much see this is human readable and machine readable, but this is really human readable, so that's what we should be looking at. So further back down the line, we can see again when the coffee was purchased and who purchased it, and for how much it was purchased for. So that's pretty much how we can see the provenance of coffee. So you can get this slide eventually off the GitHub, and that's the sort of coffee ID cup number that you could use to show that. So at this stage, we've pretty much got through the first half hour of the sort of executive overview, the high-level overview of blockchain and supply chain. So I'm just going to see if anyone had any questions, any comments about what we've seen so far, before we jump into some of the more technical details of the presentation. Okay, I see something here. I see a question. Let's see. Chat. Okay, here we do. I'm so sorry.
Oh, he didn't.
Oh, I see. Okay. Let me see. All right. How can one get in-depth and hands-on mentored or live training on IBM blockchain? So generally, we are developer advocates, and our idea is to show off the technology and get you excited with the technology, get developers as well as executives excited about the technology. But we do give workshops. We are going to give a workshop on March 11th, and you'll see that in the final slide. So we will be doing some hands-on mentoring and help with actually building one. Today, we don't have time to do a hands-on workshop, but if you would like, Gene, thanks for your question. We will be tackling that in a live workshop on the 11th. Otherwise, if there is a business relationship emerging, there is the IBM Garage, which will also provide professional services in order to get a more robust production-ready blockchain set up. But we could take it offline if you like. You can contact me on some of my, on LinkedIn or my email, and we can take that further. We see another question here. How long does it take for consensus to be reached by the parties? Seconds, minutes, or hours? So this is a very good question, and I think it comes somewhat from the Bitcoin world where consensus can take hours, if not days, because they're moving around huge blocks of the data. I'm not exactly sure how consensus works, a little bit out of my comfort zone here. I was hoping maybe we could, maybe either Leonard or Horea could chime in.
So for consensus, it kind of depends on how you actually set up your network. So depending on how many organizations you have, how many peers you have, in Hyperledger Fabric, you actually assign your own consensus policy. So you get to choose which peers does this transaction get sent to, and how many peers actually need to endorse or accept this transaction before it gets written onto the ledger. So the more peers that you select, so let's say if you have 100 peers, or I don't know, a huge business network, and you have 100 organizations, if you say I need every single one of those peers to accept this transaction, it'll take a little bit longer. If you make it only 3 or 4 out of these 100 organizations need to accept this transaction before it gets put on the ledger, then it'll be quite quick. The metric that I heard was it was in the hundreds per second. I think it can reach thousands per second, thousands of transactions per second. I think Visa or something like that is about 18,000, and I think Hyperledger is reaching about, with some performance optimizations, I think it was reaching in the thousands of transactions a second.
Yes, thank you, Horea. Actually, that's true. We have a thing called IBM TradeLens, which is another somewhat related to supply chain, but there we have container shipping records, and I believe it's 1 million transactions a day going through the system. And one of the key aspects of the performance of these systems is how much you actually put in the ledger and how much of the data you keep off-chain in basically as URL links into outside databases. So in the blockchain, you would never store a large video file or even an X-ray image or anything digital. You would merely keep pointers, and that would sort of give you the performance you would need. Yes, another question again. Thank you. I'm not sure about the whole idea in a private, permissioned, trusted blockchain like Hyperledger Fabric. We don't have tokenization really at this point. It might be coming out in version 2.0. We will have Fabric tokens or Fab coins.
Yes,
those are mainly incentivizations. But I believe the consortium will pay the cost for the computing power. So it depends on the consortium member, and I believe if you're a regulator or if you know, depends on your role in the consortium. Some may pay more than others. So I don't know an exact answer, but that's certainly something we can put in the GitHub as an issue, and we can try and follow that up. So thank you. Okay, so I was going to show you this Blockbean application running in Visual Studio Code and show you pretty much a live example how we've coded this. And let's bring up a couple of screens here. Let's shut down the show for now. So the key thing to look at here is, in this case, I've already set up a lot of the requirements for setting up a Hyperledger Fabric blockchain extension in Visual Studio Code. There's a fair amount of requirements needed, and it would take too long for us to go through and install everything. But essentially, you need Visual Studio Code, you'll need Docker, Docker Compose, I believe Node version 8 or later, and I think some npm packages like Yeoman and the loopback CLI. However, all of this luckily is in our repository, which you would be cloning. And if we take a look here at the repository, I'm going to actually bring it up in this window. It might be a little easier to see. I've previously done a git clone of our repository. So you might ask, actually that's my batch ID, which I'm going to need later. So I'm going to go back in here, and this is my terminal. So everything is running. So I've had everything running in this instance. So it is working, and it's all been preloaded, just also for time's sake. But if you can all look here, you can see where exactly. So this is the repo that we're using. So this is the GitHub repo that Hooray has put together, and I've been contributing into the repo as well in order to fill in the gaps with the Hyperledger Composer pieces that are missing, mainly the loopback. So these are open source projects, so anyone can contribute and help us improve on our code and design patterns. So I will put this into the chat, I believe. Let's just put it in here. And of course, these links are all available in the presentation GitHub repo that you will get later. So things to note in here, I guess the key thing in any application that's going to do blockchain is there's something called a smart contract, and it's here we have it under the lib folder. Now everyone is always like, when they hear the word chain code or smart contract, they're like, wow, this sounds like magic. What exactly are we talking about? And well, it's merely code that allows every peer. So every peer will have this code installed on it, and it allows transactions to interact with the local ledgers and add them to the blockchains. So in our case here, we're going to see quite a few methods that would be part of the Blockbean project. So adding members, so we'd be adding regulators and shippers and all sorts of participants involved in the life cycle of the supply chain. Here's our lovely pour cup, which we did earlier, and we can actually demonstrate pouring the cup in a few minutes. And I'm not going to go through all of these, and you could look at these at your leisure. As you can see, this is a large file, and there's a lot of things in here that would take far too long for me to explain, but nevertheless, we will see them now in a format called Swagger, and it'll allow us to interact with the contract. So this contract has previously been packaged and is available in this blockchain Visual Studio extension. So ordinarily, you wouldn't have this on your machine, but you would do your extension icon here. It's this square, strange-looking square tile, and you can see here what I have enabled. And in fact, I have indeed installed IBM Blockchain Platform extension, and it is a very nice extension, and this allows us to bring up a blockchain network, establish a peer and a single channel, and create the basic network for the hello world, or the very basic blockchain network. Obviously, in production, you would have more peers and more channels, and it gets more complicated. But this is really just a starting point, so that you can touch and say, oh, wow, I've created a blockchain application. So this is very exciting. I have this extension is out. Please note it is available for experimentation. It does change from time to time. So caveat emptor. But nevertheless, it is working right now. So I'm going to show you what's going on. So we'll close up the extension panel, and once you've installed it, you'll see this little square IBM Blockchain Platform icon on the left. And in here, you'll notice 3 panel windows. And you'll see we have a smart contract, which has already been packaged. And the important thing to note is we can take a look at that. And in fact, if we are careful, we will actually be able to create a new smart contract package by adding a new function that does very little. But I can show you how the packaging process works, and this is important for your smart contract developer. So we'll go look at my contract for a second, and let's have a look. I believe we have an init function, and this is just how smart contracts are instantiated. I'll just create an init2 function, and then this could be anything else, right? It could be some other function that does something else to the blockchain. It might check balances of money, or it's a business logic. So nevertheless, yeah, we have actually indeed updated the contract with a new function. It does nothing, which is fine, because we don't really want to use it to affect the blockchain. And if we did want to, we would then go ahead and we would call this function down here called the put state, and that'll actually put like a cup ID and the coffee in it. But in this case, we're just merely playing around. We're going to go up and update the version in the package.json of the smart contract. So we'll make this version .2. I'll save that. I'll come back to my home page, and now I'm going to package it. So you'll notice a couple of things of interest here. You'll see there's an output window in the bottom, and a little status toast pop-up. And you can see here, indeed, version 0.0.2 was created. So this is all well and good, and that is a good sign. And in the log, we also see that this version 0.0.2 has been packaged. So now I'll go back to my blockchain extension, and lo and behold, you actually see there it is. We have the new smart contract, and it's been packaged, ready for use either on our local system or in any sort of cloud service, the IBM Blockchain Cloud. So now we can take a look at the other two windows and just examine this, if we would, for 1 second. Notice that on this existing blockchain network, we have blockchain version 1 installed, and we have blockchain version 1 instantiated. So we can do a hot swap on the peer without bringing down the channel and the whole network, and still be able to keep the integrity of the blockchain itself, because merely we are just going to update one of the Docker containers that run the actual blockchain peer with the smart contract installed on it. So I am going to see about, so if you wanted to, you could click on Upgrade Smart Contract right here, or you could click it over here. I like to do it here on the panel. It feels more intuitive. So we're going to upgrade the smart contract. Notice it gives us a choice, and here we can see version 2. I'm going to click on that. I'm going to choose the peer where I want it, and in our case, we have a single peer. Pretty meaningless name, unfortunately, but you know, this could be shipper.org. upsxf.com or something. And then the function we're going to try is we're going to try our new function, which is init2, and we know that there weren't any arguments to that. So it takes a short while, and it is actually indeed, believe you me, bringing up a new smart contract peer, and we have a successful message. And at this point, it might be interesting for you to see in a terminal window, perhaps if we did a Docker PS. I apologize for the font size here. Ordinarily, there's a better Docker command just to give you less information instead of more. But I will highlight here that you can see a new container was created 23 seconds ago, and you can also see what was happening 23 hours ago when I was preparing for the demo. So, in fact, this top container will take precedence, and the one that happened 23 hours ago will be superseded. So that's the way Docker works. So indeed, we have updated the smart contract, but we've left the other containers around. And if we would, for a moment, just take a look, for those of you inclined to understand what does it mean to bring up a network. And I'll go through these really quickly. We have something called an orderer, which is essentially a container that has a Kafka infrastructure, and ordering is important in blockchain so that things don't get out of sequence. You don't want to withdraw 1 million pounds of sushi from the from the storage refrigerated storage facility if it hasn't been shipped there yet. So ordering is really important. Another one we have in here is the certificate authority. So in order for these networks to work and to be trusted, identity is really important. So we're using TLS or SSL. So we have public-private key cryptography, and that's really important. And that identifies who's who in the network. So that sets up the element of trust. Here we have our peer. And this is the one that's been up for 23 hours. And the other one to note is a Fabric CouchDB. So you might ask, well, what's in the CouchDB? In a nutshell, the CouchDB contains world state. It's really an optimized double entry of what is in the blockchain for optimization. Since we can use CouchDB's NoSQL MapReduce functions, we can get to the data much quicker rather than using search techniques along a linked list, which essentially a blockchain is a linked list. So these are just, it's really there for optimization purposes, and it doesn't have to be CouchDB. It could be any other NoSQL database or key value store, if you would. So these are the basic elements of the system. So let's just dig in a little further. Over here, we see we have a channel called My Channel. Here's our peer. We have an organization. And if we felt like it, we could actually go down here and look at the channel and notice here's our chain code. And notice we can actually identify the functions that are part of the smart contract. And the thing to note here is init 2 is actually showing up. So we have updated the smart contract. And so now we're pretty much set up with our network and ready to roll and start creating a client in order to query this network, which appears to be up and running. And we will just leave it over here in this window. And now we'll move it over to the left. And over here on the right, we're going to leave the live folder alone for the moment and go into the web app. So the web app is essentially a Node.js client that has a loopback REST API shimmed on top of it so that we can query the blockchain via an API that talks to the blockchain network using a wallet and identities and basic IP addresses and ports. So this is really important to look at. There's a lot of code in here, and it is confusing, but I will try and show you just some of the fundamentals that just to put you at ease. So one of the key things I think we should take a quick look at is the network YAML. The network YAML basically sets up the configuration of how things connect to the network. Notice here, my channel matches my channel over here. Our orderer, the peer appears to be the same. You can see the organization is the same, our peer is the same, the certificate authority. So everything looks good. We can also see there is a port listening on the gRPC. I'm not sure what that is. Aurea, do you know what the gRPC actually stands for again?
I'm not sure actually. I think that was I know that's it's like a node module, I believe. Actually, yeah, I'm not 100% sure, to be honest.
Oh, okay. All right. So, but fundamentally, these are the connection parameters that allow our client to talk to the actual blockchain network. So that's set up in the network YAML. And then other things to notice is in order for our application to talk to the blockchain network, we do have this piece of code called the blockchain client. Again, this is a fairly complex piece of code. As you can see, it's a long file, and ordinarily it wouldn't be so long, but it is long because the block bean architecture and application has a lot of endpoints. But we will just see a couple of things here. I'll just point out that make sense. So notice how we're using the Fabric network NPM library to connect. So there's the SDK. We're using a wallet that we exported from our actual network. And the wallet, it's not to be confused with a cryptocurrency wallet. It's merely a place where your private and public keys for your identity are stored. So here we have, I don't know if anyone here is technical and wonders why this file has got the extension .ts. The reason you see that is we are using Loopback, and Loopback is one of IBM's open source projects, and it is written using TypeScript. But TypeScript shouldn't scare us because it's essentially ECMA 6 compliant, and it actually adds a lot of value and productivity in building a client. But you could, in essence, build it all in JavaScript. So notice we have a couple of helper functions here connecting to the network. We have a gateway object. Notice the identity of the person connecting is this admin email address. Here's our network YAML file, which is set up. And we have a gateway connect function. And then we're able to pull a network object out of this from the channel. And then similarly, we're able to actually go and grab the contract, the blockchain bean 2, which we actually installed. And it doesn't care about the version, it just knows it by name. So that's the basic helper function. We do see some other functions in here, like adding members. So these are typically adding the grower, the regulator, the shipper, the key members in the supply chain in our coffee example. A couple more functions which are useful. We can actually query by a key into the blockchain. So every element in the blockchain is keyed, and it never gets replaced in the blockchain. It merely gets added to the head of the blockchain, or is it the tail? I forget. It's not the beginning, it's the end. It's the end of the blockchain. So it appends, it's append only, but it will update it, and through consensus mechanisms, this can be controlled whether or not it's a valid transaction. So we do have the query by key, we can query by all, and these are just helper functions. And then lower down in the code, we can start seeing some of the other functions, which I'm not going to go into detail, but they all pretty much are going to relate to the REST endpoints that we have in our system. So that's the blockchain client. It's pretty much a universal client library. It could be refactored a little to separate the network parts from the business logic parts, but we haven't had time to do that yet. So there's our client. And the thing about Loopback that you should understand is we have two things in here that are of importance to us, which are controllers and models. And controller is merely, let's take a look at the pour cup controller. These essentially define our REST endpoints. We can see we have a pour cup controller. It has a post called pour cup, and I believe it's going to take our cup ID and a batch ID, and it's going to allow us to do essentially what we did on that nice user interface. So there's our pour cup, and the pour cup has a model. And the nice thing about this is the model defines what actually a pour cup looks like in terms of the JSON input. And here you can see we have, again, an interesting decorator called model name. We have types. This, in essence, is TypeScripty. You can do this in ECMA 6, but it's much more elegant to do it in TypeScript. But like I said, you could do this in JavaScript, ECMA 2018, and eventually TypeScript and ECMA 6 or ECMA will eventually, I believe, merge. So at any rate, so we have a model, we have a controller. So let's see if we can start up our client. And I believe our client is running. And ordinarily, I'll just bring your attention to the README, which is fairly long-winded, and again, too long for us to really delve into in the scope of this webinar. But nevertheless, here we have a very nice Markdown file that walks you through how to basically create this application. So we see some pictures we're familiar with, but the key thing is, here are your requirements. We'll go down to the submit transactions, and we will see, to get this thing started, you would do npm start, and that's indeed what I've done. And that's what we see down in this terminal window. And in order to see your application, you would go to localhost port 3000. So let's see if we can find that. Now, this has a lot of data pre-canned in it, so I'm not going to refresh the page because this is how I loaded it last night, and it does take a while, but I will show you some of the key elements of this. So if any of you are familiar with OpenAPI or Swagger, this essentially is a test harness in order for you to test and explore your APIs. So for instance, we can perform some of the API calls we've already done already. So I would say let's take a look at the one that we just called, the pour cup. So notice here's my pour cup API, so I can actually call it from here. Obviously, in the real world, this would actually be like a React application or something else, whatever your favorite front end would be. I'm going to try to reorganize my screen here a little bit, see if it works. There we go. Let's get this one done here. I'm just showing you the logs. It's quite nice to see the logs happening in real time. So there's two logs we're kind of interested in. One is the output. So this is essentially the blockchain smart contract code being called. And here is our node output. And we're going to go pour a cup of coffee. So the cup ID is, I'm going to cheat a little bit, and I'm going to steal it from my previous call, just because it is a little arcane. Let's see if I can find it here in the logs. There we go. So the important thing about once this whole network's been set up, we do create a concept of a batch. So there's batches of coffee, and as you probably all know, coffee comes in large bags, and I guess batches then get roasted and shipped, and which basically make up the quality of the coffee. So let's go ahead and put in the batch ID that is relevant. And it's very nice. We can see it specs a string. The cup ID in this case is this NJB123. So let's do NJB125 just to be, and we'll put in this transaction ID. So there you have it. In theory now, if all goes well, I should be able to pour a cup. So I'm going to click execute. And I will see pour cup NJB125 was added to the blockchain. Great. So our system is working. It actually talked to the blockchain network, and the client worked as advertised. So you might say, well, how can we confirm this? So I made a few, so the nice thing about working on these projects, I was able to add an actual blockchain controller, which basically will go get things by key from the blockchain. So in our case here, we're going to go and take a look at pulling back something by key. and see what we get back. So again, I apologize for shifting around like this. Normally the user interface would be, oh, I did lose my, did I lose it? Oh dear. Oh, there we go. There's my cup ID. I'm going to copy that. And I'm going to pop it into, so I'm going to query the blockchain by key. So everything is keyed in the blockchain. So if I pop this in here, execute it, notice it's connecting to the Fabric gateway, connects to the channel, and lo and behold, it brought back my barista's name, the batch ID, all that information we saw on the user interface. So what we've indeed created here is a blockchain application that talks to a blockchain network. And this is shimmed by a REST interface. So it would be it's not a hard leap of faith to go ahead and create a React application that would use something like Axios and promises to create a real-world blockchain application. So just another nice thing I did, which was I actually like to use Chrome in this case. It has a very nice JSON viewer. So there it is. We just did this, but we did the code ourselves. So if we look at this, again, I can just query it in here. The JSON's a lot easier to see. And then, indeed, I could look at the whole batch that was involved in this. And this batch, oh, okay. We see an internal server error. Perhaps that was not the right batch. Let's take a look at the entire, let's see what happens here. Oh, okay, we had the wrong batch number. So an error 500, of course, is not exactly the right. We should have got a 404 or something a little more friendly. Oh, okay, good. So now we can look at the batch by key and notice we see the entire history of this blockchain for coffee. A little hard to see it in terms of time and timeline, but we do see the ship that was involved. There was no insect activity, who the grower was, how much was spent, $43,000. So there was a lot of coffee. The flavor score, etc. So this is very nice to see that we've actually created a blockchain, and it didn't take that much effort to do it. So I'm going to switch gears now and go back to my PowerPoint presentation just to take us through the rest of the presentation. Let me see now. It is over here. Okay, great. So we pretty much have done this. I love cake stacks, and this pretty much summarizes what we've just looked at, right? So this runs on an internet or local host or on the cloud. There's containers, Kubernetes, Docker. You can choose your poison there. Hyperledger Fabric Basic Network is what we did in our examples now. Or you could use the more robust IBM blockchain platform, which runs on the IBM cloud. And the reason you do that, of course, is for security, scalability, and high performance. So indeed, the IBM blockchain will run on Z systems, which is our mainframe and architecture. I believe on Power 9, and who knows, maybe it's coming soon on the unmentionable quantum computers. We've used Visual Studio Code in the IBM blockchain platform extension, which is very nice. And again, that's also contributed by IBM into the Visual Studio Code open source repositories. We took a look at smart contracts. These were written in JavaScript. And then we looked at the client application, which was using a REST API, using the loopback libraries. It's a Node.js application using NPM, and in our case, it's fairly dependent on TypeScript, but never fear, it's not far from the JavaScript paradigm. And I have written many projects using TypeScript, and it's actually quite gratifying to get IntelliSense and strongly typed JavaScript. That's just my kind of my flavor. So here is, you can get the slide later. Pretty much there's the URLs for you to try it out yourself if you wanted to. The README's there, it's all there. It's working, as you could see. And here's a description of the actual code pattern. And I believe the code pattern is not absolutely up to date yet. So you would want to try the top link for now, and the code pattern will eventually be updated in the very near future. So you might ask yourself, well, you've just created this fantastic application, and it's running on my laptop. I showed off to my friends and colleagues, and impressed my grandmother, and like, well, what do I do next? So IBM has announced IBM Blockchain Anywhere. So what does that mean? Well, you can pretty much deploy it on our cloud and use our infrastructure, or you could use something called IBM Cloud Private, which allows you to pretty much run the IBM Cloud on your own infrastructure. So on premise, maybe a bank or a government institution, and you don't want to be part of the public cloud or even dedicated data centers. You want everything on premise. You could do that. And now, of course, we also run on all the other cloud providers of note. So, of course, Amazon, Google, Azure, Oracle, SAP, and least but not last, Alibaba. So what have we learned today in this webinar? I hope I've given enough information, and it's been useful for you guys. But we've basically noticed the basics of blockchain. My spelling is terrible, I do apologize, for business and enterprise. So we understand the concept of a distributed ledger, which is a distributed database. It's distributed, so it's single, meaning it's replicated. There's no multiple copies of data anymore. This can be shared privately amongst trusted communities. We've understood that Hyperledger is the open source Linux foundation for managing all sorts of blockchain technologies, and seen the contributions that IBM has made specifically to Hyperledger Fabric. We've also taken note of a few of the supply chain solutions, ranging from Sushi, the hypothetical, to diamonds, which actually exist today. Not only the IBM, even De Beers has their own Verite diamond tracking solution, which is written on Ethereum, using Ethereum, which, by the way, we do support as well in our Hyperledger Fabric. You can run Ethereum smart contracts inside Hyperledger Fabric, but that's a topic for another day, and it is more advanced, and I know Horea has done that, and he has some videos on that, so I will try and include those links on the GitHub. We've seen a technical demo of the Bean demo using Visual Studio Code, and the really nice IBM Blockchain Platform extension, which, by the way, I might add, has added a huge productivity increase to the README docs from the actual Hyperledger Fabric website where everything is done through shell scripts, and it's pretty much a command line experience, which some people like. I'm a big VI command line hero, but I think the Visual Studio Code is taking us into levels of productivity we never saw before. I was going to show you how to develop everything from scratch, a prototype of a tic-tac-toe game, but I think we are running out of time. But it'll be on the GitHub repo, and perhaps that's something we will do in the workshop on March 11th. So I'm going to open up the floor for any further questions from anyone, comments, feedback. So we've got about 15 minutes. So if anyone has any questions, I see we do have a couple more questions. Okay. Thank you. I see one here. Good and useful presentation. Thank you. I like the technology slide and code. Thank you. Question. Is there some existing compliance requirement on the books in USA, Europe, Asia, demanding each party along the entire chain to keep track of the info in an auditable, rigorous, and standardized way, requiring blockchains? Or at this moment, is it up to a group of business entities to agree to use blockchains? You know, I'm not entirely sure. I think Leonard might be able to add some insight to this question. Are you still there, Leonard?
I'm here. I don't totally understand the question. Can the person who asked the question maybe give us some more details about what he's asking?
Yes, I'm trying to see if I can give him voice control. Let me see. Unfortunately, I only see the participants, essentially, what would motivate a company to use blockchain? The key thing about using blockchain, if you're just a single company and using it internally, the motivation internally by using a blockchain would be you wouldn't have silos of data. So if I was a bank, Goldman Sachs, for argument's sake, or Citicorp, or I don't know, I don't want to name any banks, just in case I get into trouble, but, you know, Acme Bank, the point there is by having a blockchain, you would do away with end-of-day reconciliation process, which takes hours, if not, hours and hours, like batch processes. You'll have immediate access to the data. You wouldn't have delayed data. So that would motivate a single company or even a group of global companies to use a blockchain. And I guess the other use case would be if companies were working with other companies and they wanted to share data that was useful between them, but they could choose and decide what data to share. So one example I like to use, of course, is the gambling world, where if you go into a casino and you happen to be a professional card counter, they do catch you out eventually, and they will use facial recognition and take, you know, your credit card details and your car registration plate, and that data gets shared amongst a consortium of policemen of casinos. So if I go into another casino, they can pretty much march me out. So there's some motivations to share data, even if you're a competitor. And then, of course, the main compelling reason would be, you know, if you are in a transparent world and supply chain and you do need to share data, your important data. I would like to say that our CEO, Ginny Romity, just announced fairly recently that Delta Airlines is now going to use blockchain technology to share with hospitals in order to move organs that are needed for transplants. And the reason blockchain would be really helpful here is the transparency. So the hospital could immediately see where the for instance, the kidney was in the air, was it in the correct temperature in the chamber, was the heart in the right, when you see a heart being moved around, it still beats, they have electrical signals. So you could immediately tell whether or not you're going to prep the patient and know the heart is going to be there like in half an hour. So there's a lot of motivations to use a blockchain. But that said, the blockchain is not a silver bullet, and it is decentralized. It can be slow in some cases. And if you wanted to write a low latency, high frequency trading application, blockchain may not be, you may want to use a centralized architecture, which would be highly performant. I don't know, does that answer your question? Oh, okay. I'm afraid I don't know about that. Do you see this question, Hooray?
I see it, and certainly blockchain is incredibly promising and is being used in more and more use cases.
So one specific metric that I know the IBM Food Trust has come out with is that I think, so they didn't have a specific ROI metric in terms of monetary value, but they came out with a metric that said it took them 2.2 seconds to track a particular batch of mangoes, whereas before, without the blockchain system, it took them days. So it reduced the time to find out, if there's an infestation or if there's a recall or something like that, you're able to pinpoint exactly where that batch is coming from in seconds, whereas it took days before. So that was a pretty big announcement. But in terms of ROI, I don't know if there's specific actual ROI metrics that have come out yet. Everything is still very it's still pretty new. Walmart only required their suppliers to join the blockchain only a couple months ago, so it still is pretty new for the production networks.
I believe there are some metrics. I think I have a Forrester research article lying around. I think it is in the public domain. I'll have to check first. And if indeed it is, I will post it on the GitHub repo, which you guys will see at the end of this Q&A. And it'll also show you how expensive it is to build a trade lens application for Walmart. So, you can be a mom and pop shop and build, you can definitely get started and build applications using open source software, which we did today. But once you start pushing it up into the cloud, there are associated costs. And I think the key cost here, if we compare private trusted permission blockchains to say Bitcoin or Ethereum, we don't have the idea of tokenization. So tokenization is how they pay for the computing power in order to solve the cryptographic puzzles. In our case, if you're going to create a Hyperledger Fabric blockchain network, it's up to the consortium to pay for the computing power. So, like I said earlier, it's all up to the governance. So somebody will figure out who's going to pay more and who pays what. But I believe it's, once you go professional like that, it's pretty expensive. But the point is it does cut down your auditing costs. You can cut out a lot of the middlemen. People are buying houses, you're cutting out, property rights, surveyors, all these reports that cost, tens of thousands of dollars just because records are now being kept on the blockchain. So there are some good use cases for why you would use blockchain. But maybe this could be a future topic. In fact, if anyone has any ideas of things they'd like to hear more about, I'd love to hear from you, either here in the chat, or you can post issues on the GitHub repo I've created, or even contribute to that repo, and we could set up conversations there. But I believe, we've just really touched the surface of Hyperledger Fabric and blockchain here at IBM. All right, so we have 3 minutes left. So I think I'm going to ask if there's one last question, comment. I'll take that. Oops, there we go. So this is my last slide. So I'm going to be giving a meetup on March 11th in Brooklyn. There's the link to the meetup. Currently we have 40 people coming. We only expect 1/3 of that, so probably 12 people will be there. So I do encourage people to sign up. It will be a hands-on workshop. It'll be longer than this. I believe it's 2.5 hours, and we'll actually be doing hands-on coding with Visual Studio Code, going into some more of the academic details behind Hyperledger Fabric. And if you liked and you wanted to play around with the IBM Cloud account, there's a trial account you can sign up for. It's a free account. It has limited, it obviously has some limited APIs, but there's quite a lot of good stuff on there, including the latest IBM blockchain platform 2.0, which really is Fabric 1.4, which is what we played with today. It is in beta, so caveat emptor, may break. The link you see here in yellow is the link that will work today, tomorrow, and then pretty much, I believe it's only for a couple of days. But when that link starts failing, the other link here will allow you to create an account. This presentation and the GitHub repo that will contain these slides in SlideShare, and also, please feel free to, collaborate on the presentation or comments, etc. It's in my my Developer Advocate GitHub repo, which is delineated here, and I'm going to just use I really love this new feature of PowerPoint. So that's the URL there. And I will post it in the chat real quick too. Let's see how good my typing is. So thank you everyone for joining. I appreciate it. Any feedback, feel free to contact me either via my contact information is on the slides. And I believe if we click on this, we will see a lovely GitHub repo that I've created. If I can make it full screen. So here we have just it's a very simple repo. There's not much in it. Really, just the README, but it has the links. It has some of my contact information, yeah. Thank you. I appreciate everyone for joining, and we look forward to having you come back, and we can produce more webinars. And the questions were very, very nice. So thank you. Oh, I see. Okay. I see these links aren't clickable. So maybe take a screenshot of the link. I apologize about that. That's WebEx for you. Sorry about that. All right. Thank you, everyone.